Hello, welcome to our session again. This time we will solve a problem of differential equations using Bernoulli's equations. So again, Bernoulli equation have two equation. It's either linear in x or linear in y. So for this one, we will determine if it is linear in x or we can use linear in y. Okay, so to start, this will be our problem. Y quantity 6y squared minus x minus 1 dx plus 2xy dy is equal to 0. So again, this is our solution to this problem. Okay. First is, let's just copy the problem. That is y 6y squared minus x minus 1 dx plus 2x dy is equal to 0. Then next is we need to distribute this y to the inside variable. Okay, that gives us this one, that is 6y cubed minus xy minus y quantity dx plus 2x dy is equals to 0. If we transform this from dx over dy or dy, if we can transform this, from dy over dx, we can have our equation like this: plus 6y cubed minus xy minus y all over 2x quantity, this is equals to 0. Okay, so from this we can have we can determine if it is linear in y from this our equation. Okay, then to proceed, we can have extract the fraction. So that will become dy over dx plus, that is 6y cubed over 2x minus xy over 2x minus y over 2x, and then that is quantity equal to 0. Okay. So from this we can cancel out, so this will become 3, and then this is just it's y over 2. Okay, that's y over 2, and then this one is y negative y over 2x. From that we can have this equation, dy over dx plus, then let's isolate this one. P of x in terms of y, or we can have, let's just simplify this one. That is 3, that is 3y cubed over 2x. That's 3y cubed over x. Minus y over 2, then minus y over 2x is equals to 0, and then we have quantity. From the property of Bernoulli equation, if we have the linear in y, this is the general formula. General form for Bernoulli equation. It's equals to q of x, y raised to n. So this is the general form of Bernoulli equations if it is linear in y. So therefore we can have, or we can aim that this can be transformed to this general form of Bernoulli equations. So if that's met our condition, so therefore the equations now will be Bernoulli equations. Okay, so let's proceed. From that is dy over dx plus a. We can factor out this one, p of x of y. So the answer is this one, that is negative 1/2 minus 1 over 2x, factor out y. Okay, this one, factor out y. S equals to, in this one, let's transpose this. This will become, this is negative 3 over x. Okay, and then this is y cubed. Okay, from that this one is dy over dx, and then this whole is our p of x, and then this one, this is our q of x, and then this is our y n. So therefore the equation now is Bernoulli equation. Okay, to do that we have a formula to solve for Bernoulli equations. Okay, this one will be formula, so let's solve it out. If we have Bernoulli dy over dx, the formula is this. We have y, we have 1 minus n. Okay, and then this one we have e integral of, we have 1 minus n. Okay, and then we have p of x. Okay, and then dx plus c is equals to integral of this 1 minus n. Okay, and then p of x, then this one we have e integral of 1 minus n. No, that is q of x, sorry. This one, that is q of x, 1 minus n, p of x, okay, dx, and then this one dx plus c. This is the formula. It's a very long formula for Bernoulli equations, but don't worry. Dx plus c. Did you observe that this term is the same? Okay, can we call it as integrating factor, IF? Is integrating factor IF. Integrating factor. To solve for it, to do this easily, we can solve first the integrating factor by just doing this. Okay. Integrating factor is equals to e 1 minus n. We have p of x dx plus c. Okay. We all know that our n is 3. Okay. So this one we have e, we have 1 minus 3. Our p of x, again this one is negative 1/2, minus 1/2 x, okay, plus parentheses dx. Then from that, we can simplify this one. This will become negative 2 e, this is negative 2, and then integral of negative 1/2, okay, can we simplify that, dx, minus integral of 1/2, oh no, that's 1/2x. Sorry. It's 1 over 2x. Okay, 1 over 2x dx, and then this one, quantity. Okay, then plus c. Okay, from that we can integrate it directly. This is e to the negative 2. This will become integral of 1/2 dx is negative 1/2 x, okay, minus integral of 1/2 dx over x, that is 1/2 ln x. Okay. And then from that we can cancel out. Let's notice that is negative 2, 2 is 2. Okay. And then this one is positive all. So the remaining equation will look like this: e is 2x, okay, plus ln x. Okay, from that we can have ax, or we can rewrite that as a ln x. Okay, but we all know that e ln is just equals to 1, so therefore this will become 1. So our integrating factor, this will become x ex. Okay, this is our integrating factor. Okay, so therefore this will be now our equation, our integrating factor, that is x ex. Okay. From the formula, when we copy it, so we can have a guide. From our formula, again, that is y, and then 1 minus n, and then times integrating factor. Okay, this is a shortcut formula. Yes, integral of, again, 1 minus n, and then, okay, times q of x, and then times integrating factor, and then dx plus c. Okay, the formula now is little bit simpler, and then from that we can directly substitute that our n from our problem, that our n is equals to 3. Okay, that is y. It's 1 minus 3. Our integrating factor is this one, x ex times x ex, and then integral of, again, that's 1 minus 3 again, q of x. So what is our q of x? Our q of x is this one, that's this negative 3 over x. This one. Our q of x is negative 3 over x. That is negative 3 over x times the integrating factor again, that is x ex, and then dx plus c. And then from that we can simplify again. Okay, that this is y to the negative 2 times x ex is equals to, again, this one, that is this one, that is negative 2, and then negative 3 over x. Okay, and then we have x ex, and then this is dx plus c, and then get the integration. And then for this can be simplified as x ex over y squared is equals to this one. This can be positive, and then this is 6. Okay, then integral of this can be cancelled out. Okay, positive, and then this x cancelled out. So our remaining equation will be this x, isolate that, this ex dx plus e plus c, and then so therefore we're done in this portion. So let's do this integration again. Okay. From that, let's copy this again. X e raised to x over y squared is equals to 6. And the integration of ax dx is just ex plus c. And then after that, let's do a cross multiplication. We have x e raised to x is equals to 6 y squared, that is ex, plus that is c, then y squared. If we can divide it both sides by ex 1 over en. Okay. This can be cancelled out, and this can be cancelled out. And then we have here a negative x. Or we can have this, cy squared ex. Okay, and then from that, our equation look like this: 6y squared plus c y squared all over ex. And then we can place the denominator to the numerator by getting the negative sign. Okay, this will become x is equals to 6, that's y squared, plus c y squared, that is e negative x. Okay. And then factor out y squared, so x is equals to y squared, that is 6 plus c e to the negative x. Again, so this will be our final answer for our problem. This is the general solution to the problem. Okay, we have a quick review. That's very long solution, but the concept is need to understand the basic properties of Bernoulli equations. Again, from this problem, let's transform this to Bernoulli in y, that is dy over dx. Then after transforming this one, okay, this will be the general form for Bernoulli equations in linear in y. Is dy over dx plus px of y is equal to q of x y n. So from this, we can have this dy over dx actually met the condition of the general form equations of Bernoulli equations. And then from that, this will be this is the formula for solving Bernoulli equations. If Bernoulli in y, the formula is y 1 over less to 1 over n times e 1 minus n raised to 1 minus n p of x dx plus c is equals to integral of 1 minus n p of x e raised to integral of 1 minus n p of x dx. Okay, this one actually this is integrating factor, so don't worry. Okay, after that, let's solve first the integrating factor, so we can actually eliminate those long solutions. We can or more variables. After this is our integrating factor, that is only x ex, and then from that we can directly substitute to our equations. This one. Then next is get the integration or cancellation method. If if we can cancel variables, then from this we can arrive the answer. Our solution to the differential equations or Bernoulli equation is x is equals to y squared 6 plus c a plus to negative x. So this will be our general solution. Thank you for listening.